Okay, so next we could talk about what about not every hyperbola is centered at the origin. So let's look at the ones that are not centered at the origin. They're centered at h comma k, h for the x coordinate of the center and y for the k for the y coordinate of the center is a common notation here. So once again, we are going to have sideways hyperbolas, what I'm going to call sideways, where and actually shouldn't draw it like that, but just say we have some point that's our center, then you're going to have two asymptotes, and the hyperbola is going to open up to the left and to the right, sideways. And then y direction, vertical ones, again, where you've got some center, and then you've got your asymptotes through that center, and these ones are going to open up and down. So really, it's just the same game. I just play the same exact game as we've been playing before, but just be careful to graph well. And best way to do this is just to dive in and do an example. So our first example is going to be to look at here's a little bit of information, come up with everything you can. The center is at -1, 2, the focus is at 4, -2, and the vertex is at 3, -2. And so, again, graph paper is really helpful here. I'm going to give us somewhat off-centered, but a pretty good little just XY axis here. I don't know, let's go up 4, 1, 2, 3, 4. Let's go down quite a bit more, 1, 2, 3, 4, 5, 6, 7. I don't know, that seems reasonable. 1, 2, 3, 4, 5, 6, 7. And then in the X direction, let's go something like 7 as well. 1, 2, 3, 4, 5, 6, 7. And the Y direction, I don't know, we'll go 4, 1, 2, 3, 4. And we can add more as necessary. So let's see, center. We'll use a black dot for the center here. All right, our center is 1, -2. So that would be right here. And then let's see. Well, looking at the focus and the vertex. So the focus, 4, -2, 4, -2, and 3, -2. Okay, so it looks to me like this thing's going to open up left and right. So let's use, for the vertex, we're going to put blue there, vertex, and then the focus in red. Okay, so now we know our center and the vertices. So, have I done that wrong? Yes, I absolutely have. Let's erase this and actually graph these correctly. Okay, so our vertex is 4, -2. 1, 2, 3, 4, down, -2. So I'm sorry, focus. Focus is 4, -2. There we go. There's our focus. And our vertex is 3, -2. 3, -2 vertex. And now you can see what I said, the earlier advice of be careful, draw good graphs. I was off by one and it would have thrown the whole thing off because I'm going to use this picture to figure out A, B, and C. Okay, so A is the distance between our center and our vertex. And so I can see that from my graph, that's a distance of 2. A is equal to 2. B we don't know yet. B we'll have to find. And C we can also from our picture look at and find. We can say that C is the distance from the center to the focus. So it's 1, 2, 3. All right, so I know C is equal to 3 there. Go ahead and draw our triangle. A is equal to 2. B is equal to don't know. C is equal to 3. And then we use this to calculate the Pythagorean theorem to calculate B. Well, B is equal to the square root of the hypotenuse squared, 3 squared, minus the other leg squared, 2 squared. And that's going to give us 9 minus 4, which is root 5. And maybe you're noticing a theme here. All of the examples seem to be root 5. Okay, so B is equal to root 5, which is about 2.2, or involve root 5. Okay, so root 5, 2.2. Now we're ready to plot that little green, the vertical point above there. But before that, let's do it now. Up, so you start at the center and go up 2.2, so you're going to be just a hair above the x-axis. And then you go down from the center and you go down 1, 2, and just a hair more. And so you're going to be something like 1, and then 1, 2, 3, 4, 1. So this is going to be like 1, -4.2 or something like that. Okay, so now we need to fill in the rest of the vertices. A being a distance of 2 from the center, we count 2 to the left on the transverse axis. So we just go to the left from our center, and that puts us at -1, -2. And then our other focus was 3 from the center. So again, starting at the center, go -1, 2, 3, and that puts us at -2, -2. Now we've got all of the pieces, and the game becomes the same. We draw ourselves our box. And again, accuracy really helps here because I can see where things are crossing and whatnot. And you know what? We never had to draw the transverse axis, but I feel like the transverse axis going through these foci might be kind of helpful here. Oh no, what did I just do? Oh, I know what I did. Okay. All right. So we've got our transverse axis, and while we're at it, why don't we just identify that? That is a y value is always fixed, and I'm sorry I keep tapping that. That's annoying. Y is equal to -2. Okay, so we just identified something we needed to know. All right, we got our box. From here, we draw in some asymptotes. And once you have your asymptotes in, you can draw yourself a really nice picture of your hyperbola from those vertices. All right, so we've got a really nice, good graph there. We know A, B, and C. And so let's first start by just listing all the things. I'm not going to rewrite the center, but you could rewrite the center. For the focus, I'm again not going to rewrite one. I'm just going to add the other one to it. So we started with 4, -2. Our second focus, looking at our graph, it looks like it's going to be -2, -2. So our second focus will be -2, -2. What about our vertex? Well, our first vertex was 3, -2. So the one to the left of the center was 1, -1, -2, -1, -2. Sure enough. And we identified our transverse axis there. So the last thing we need to calculate are our asymptotes. And here the game is a little bit harder, but nothing we can't handle. Nothing you can't handle. So if you've noticed that the slope of our asymptotes is always the one's positive and one's negative, that's always going to be the case. Yep, that's always going to be the case. So slope equals rise over run. And I'll label them L1 being uphill, L2 being downhill, increasing and decreasing respectively. So our rise is what? Okay, so from our center, we would go vertically the B amount. How much is the B amount? √5. And then from that center, so what we just did was, I won't be able to erase this, so feel free to not add it to yours. Go from the center up in the B direction amount. And then from there, to get to your point, we would travel over the A direction. The A direction is 2. So our slopes for these two lines are going to be plus or minus √5 or 2, respectively, positive for being L1, the increasing line, negative being L2, the decreasing line. So now we need to do a little bit of algebra to find the actual equation of these. So for L1, what point should we use? Well, I argue that probably the easiest point to always use is that the asymptote necessarily goes through the center. So our slope is equal to m equals √5 over 2. And our point is equal to the center, which is 1, -2. So the equation of the line is going to be y minus -2 equals positive √5 over 2, and then x minus 1. So simplify up, y minus the -2 is y plus 2. √5 over 2 times x is just √5 over 2 times x. √5 over 2 times -1 is just negative itself, negative √5 over 2. Now to solve for y, we would add 2 to both sides, add 2 to both sides, and y is equal to √5 over 2x minus √5 over 2 plus 2. Now I'm going to, on an exam, for me, this would be fine to just leave it as √5 over 2 plus 2. However, maybe your homework wants in slope-intercept form, so let's just go ahead and remember how we would add our fractions here. To simplify this value. We would first turn that guy into a fraction. Then we say, how do you add fractions? You need common denominators. So the guy on the left has 2. So we need 2 to be the common denominator. But you can't just multiply the bottom of a fraction by 2. You have to multiply both the top and the bottom. Really just multiplying by a fancy version of 1 in here. And so what do you get? Neglecting to rewrite the rest of the problem a little bit, but not neglecting to keep track of the sign. Root 5 over 2 plus 4 over 2 turns into, you know what, we're going to give this a star so we can come back to that because we're really doing bad work here. Well, my new denominator would be 2, and I would combine my tops. Negative root 5 plus 4. And since root 5 is a gross number, we're just going to leave it like that. And so we could write our L1 equation could be written as y equals root 5 over 2 x. Oh boy, you didn't do this. It's way harder this way. Plus a negative root 5 plus 4 over 2, because you're adding this entire quantity on. You know what? Just leave it like this, unless you're explicitly instructed to change it. But that's okay. It was good to have seen and do. The equation for L2, we're going to leave it as similar. Leave it as an exercise for you to do.